Let us look at proposition number 12 of book 8 of Euclid's Elements. The proposition says, between two cubic numbers, there are two mean proportionals, and the cube has to the cube the triplicate ratio of that which side has to the side. So between A and B, there are two mean proportionals, and the ratio of the cube to the cube is equal to the triplicate of the side is to side. Okay, let's see how we can prove this. We are given two cubes A and B. C be the side of A and D be the side of B. Let E is equal to C times C. So E is C square. Let F be C times D. Let G be D times D, that is D square. Let H is equal to C times F and K be D times F. Now, when we look at H is equal to C times F, F is C times D. So we can write it as C times D, which is equal to C square D. But C square is E. So we can also write it as E times D. Okay, similarly here, K is equal to D times F, but F is equal to C times D. So which means K can be written as C times D square. A is C cube, yes, and E is C square. So that means A is C times E. C times C square, that is CE. So we can say A is equal to C times C, which is equal to C cube. B is equal to D times G. How? Because G is D square and this is D. So B is D cube. So we can write it as B is equal to D times G, which is nothing but D cube. Let's start building the ratios. C is to D is equal to E is to F. How? Because C measures E. C measures E C times. And D measures F C times. So same number of times. So C is to D equal to E is to F. Then C is to D is equal to F is to G. How? Because C measures F D number of times. And D measures G D number of times. So we can say C is to D equal to F is to G. E is to F equal to A is to H. How? Because E measures A C times and F measures H C times. So same number of times. So we can write it as a proportion. Okay, C is to D is equal to A is to H. How? Because C measures A E number of times and D measures H E number of times. Remember, H is C times F, but F is C times B. So we have C square times D, which means C square is E, so E times, so C is to D equal to A is to H. Now, C is to D is equal to H is to K. How? Because C measures H F number of times and D measures K F number of times. So again, same number of times. So we can say C is to D is equal to H is to K. F is to G is equal to K is to B. F is to G is equal to K is to B. Again, how? Because F measures K D number of times and G measures B D number of times. So same number of times. So we can say F is to G is equal to K is to B. Now C is to D is equal to K is to B. Since K is equal to C times D square and B is equal to D times D square. So C measures K D square times and D measures B D square times. So which means we can write it as C is to D is equal to K is to B. So what do we have? we have A is to H is equal to H is to K is equal to K is to D, because they are all in the ratio of C is to D. C is to D is equal to A is to H, C is to D is equal to H is to K, and C is to D is equal to K is to, and A is to H equal to C is to. So it is in the ratio of C is to. Now, if you notice, H, K, K, they are the mean proportional. So, which means there are two mean proportional numbers between A and B, which also means that A, H, K, B are in continuous proportion. And since they are in continuous proportion, A is to B is equal to A cube is to H cube, but A is to H is equal to C is to D. So, which means we can say A is to B is equal to C cube is to D cube. So, we have shown that if we have two numbers, cube numbers or cubic numbers, then there are two mean proportional numbers between those two numbers. And the ratio between these two cubic numbers is equal to the triplicate of the ratio of the sides. So that is proposition number 12 of book 8 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.